Okay, 12 Maths, Paper 2 of 2014, September 2014, and it is question 3. In this question, we are given a triangle ABC with altitude CD indicated. Altitude CD means that we have a 90-degree angle at point D. First question, write down the equation of the line AB. Now, that is very simple. AB is simply one of your special graphs, so it is y equal to 9. 3.2. In this one, they want the length of AB, and again, they say write down the length of AB, so it shouldn't be much of a problem. AB is 11 units. You simply read it off from the coordinates that were given. Then 3.3, they want the coordinates of D. Now D has got an x coordinate of 13, similar to that of C, and the y coordinate of A and of B. So therefore, point D coordinates will be 13, 9. Always when they say coordinates, give it in an ordered pair like that. 3.4. Question is now calculate the area of ABC. Now you can simply use your half base height. So it's half AB times CD, and that is going to be half 11 times 8, 11, and that is going to be 44 units. Then 3.5, in this question, they want you to determine the coordinates of M, the midpoint of AC. Now, AC being there, so the midpoint will be somewhere here. Midpoint formula is M x1 plus x2 over 2 and y1 plus y2 over 2. And for x1 and x2, well, x1 is 0, and we've got a 13, so it is 13 over 2. And y1 is 9 plus 1, that is 10 over 2. So the midpoint will be 6.5, 5. Right, 3.6. In this, hence, determine the equation of the perpendicular bisector of AC. At the moment you see the word hence, it always means that you need to use the previous answer. So they say now, determine the equation of the perpendicular bisector of AC. Now, perpendicular bisector means that if you have M, which is the midpoint, and it is the perpendicular bisector, now say M is there, the perpendicular bisector will be something like that. Perpendicular, bisecting. So we need to find the gradient of AC. They say bisector, the perpendicular bisector of AC. So we first need to find the gradient of AC, and that gradient, easy to calculate, will be y2 minus y1 over x2 minus x1. If you put in the values of those points, 9 minus 1 and 0 minus 13, you get the minus 8 over 13. Now that's the gradient of AC. Now to get the gradient of this new line, the perpendicular bisector, it's going to be the reciprocal negative of that. So the gradient of the bisector, therefore the gradient of the bisector will equal 13 over 8. So I can set up an equation, therefore y equals 13 over 8 plus c. Substitute the midpoint, which was calculated in 3.5, and you get that 5 equals, sorry, there's an x missing, 5 equals 13 over 8 times 6,5 plus C. And C works out to be 5 and 9/16. Therefore, the equation is y equal to 13 over 8 x plus 5 and 9/16. In 3.7, does the perpendicular, let's just move up a bit here, does the perpendicular bisector in question 3.6 pass through point B or not? Justify your answer using relevant calculations. So if we need to prove whether that line passed through B, then if you substitute the coordinates of B into this equation that you just calculated, if it satisfies that equation, then you know that point B will be on it. So that is how we're going to answer this question. So it's going to be 3.7, substitute B 11, 9, and then that will be 9 equal to 13 over 8 times 11 plus 5 and 9/16. If you now substitute this, you get that if you add that plus that, it is not equal to 9, and therefore line does not pass through B. Now always remember to answer the actual question that was asked, and this was specifically about the point, the line going through point B, so you need to answer the actual question that was asked. Then 3.8. In 3.8, they say determine angle ABC correct to the nearest degree. Now, angle ABC, you make sure that you understand where the angle is. Angle ABC there. Now, if you work with the fact that you can calculate gradients and that the tan of theta equals the gradient of a line, so we can use that fact to actually calculate the gradient of line BC, and that will give us or lead us to the size of that angle. So that is what we're going to do. I'm going to do it this side. (3.8). The gradient of BC will be equal to and that is 9 minus 1 over 11 minus 13, which is equal to minus 4. Now you can say tan theta equals minus 4, and theta is then solved by the tan inverse, works out to be 104,04 degrees. So therefore angle ABC equals 104,04. You could also use the cos rule to bring in a little bit of trigonometry to solve this question, because that since you have the length of the two sides, you can actually calculate what your angle is. Then 3.9, last question, determine the equation of a line parallel to AC and passing through D. So a line parallel to AC will have the same gradient. So therefore, it's y equal to, now the gradient of AC is minus 8 over 13 plus C. Then, again the x, then we need to substitute the point that it goes through, so it's passing through D. Now we had the coordinates of D right in the beginning in question 3.3, and that was the point 13, 9. So 9 equals minus 8 over 13 times 13 plus C, and then if I solve for C, I get 17. And therefore y equals minus 8 over 13x plus 17. And that concludes question 3.